Welcome back. This is lecture 6 on harmony in the Pythagoreans and what happened, I guess, to it subsequently. There are a couple of things before I go on to talk about what I intend to talk about, which is the idea of how the tetractys and the number system played its part in their thinking about cosmology in the universe. I want to just finish up some things that I forgot to mention last time when talking about harmony in music, because there is really a hell of a lot to say and I barely scratched the surface. And think of it as an invitation to go on from here and to be interested to find out about more of it. There is certainly a lot more to find out. First thing is there is a very useful, interesting book on the subject. It is this book. It is How Equal Temperament Ruined Harmony and Why We Should Care. It's by Ross W. Duffin. And that's it. How Equal Temperament Ruined Harmony and Why We Should Care. It is an impassioned complaint with many quotations on equal temperament. So if you're against equal temperament or whether you're for it, you might find it an interesting book. I thought it's full of interesting quotations from people from the transitional period where equal temperament had not completely replaced the earlier temperaments, which went probably into the beginning of the 20th century. And so we have a quotation from H.W. Poole, an essay on perfect musical intonation in the organ. He says, and this is probably the most flattering thing that's in the book on equal temperament, he says, equal temperament has this great advantage over all others. Its 12 keys can all be used. They are all tempered alike. The ear, too, is better satisfied when all the chords are equally out of tune. There you have it. Equal temperament. Ruined civilization? Probably. Yeah, it probably did. Something did. So let's continue talking about the tetractys and the significance of the tetractys for the Pythagoreans. If you like, the larger significance of it. The tetractys consists of the first 10 numbers, and it arranges them in a triangle in such a way that the right-hand edge of the triangle gives you what are called the triangular numbers. That is 1, 3, 6, 10. Now, you can continue on the triangular numbers if you were to increase the tetractys going downwards with more rows, increasing, of course, in the way that the tetractys rows do. Then you would get the further triangular numbers, which are from 10. You get 15, and after that 21, 28, etc. Goes down further. Now, the Pythagoreans believed that all of the first 10 numbers were significant, that they had a great deal of significance. This was where, as it were, much of the importance of numbers came from the first 10. And they had a number of ways of exploring that significance. One consequence came directly out of the tetractys and the triangular numbers, because the number 6 is what is called a perfect number. What is a perfect number? Well, a perfect number is a number whose proper divisors add up to the number itself. I'll slow that down. The proper divisors of 6 are 1, 2, and 3. Because if you multiply 1, 2, and 3 together, you get 6. If you were to add 1, 2, and 3 together, you get 6. So the proper divisors also, if you were to add them up, give you the number that you started with, 6 in this case. That is a perfect number. Now, what is the next perfect number? Well, it's in fact 28. And if you recall what I just said and the other triangular numbers, 28 is a triangular number. Well, that's interesting. Now, it's not easy to think initially that there's any special significance in 6, other than the fact that it's a perfect number. But what about 28? What cosmic significance might that have? Well, it's the lunar month. 28 days is a lunar month. It's the time it takes for the moon to go through its cycle of phases. What else does it signify? Well, the lunar month corresponds to the female menstrual cycle, 28 days. So here you have a perfect number, 28, and it corresponds to these two very significant features of the world. The size of the length of the lunar month and the female menstrual cycle, which corresponds to something to do with fertility for the Greeks. Now, these are interesting. This is an interesting correlation, and I think it's rather likely that the Greeks over-exaggerated this relation, took it to be something more than a coincidence. They took it to show something about the perfection of the cosmos. What then did they do with 6? Since 6 is also a perfect number. Well, that's a little harder. It's not obvious that 6 has a cosmic significance. 7, you might say, does, because it was the number of planets that the Greeks knew about. They knew of 7 planets. What about 6? Well, that becomes tricky, but it's an interesting question that sort of leads out into this further field. The creation of the universe in the Bible is 6 days. Why? Why 6 days? What does a day mean in the creation of the world? What does that mean? Well, it's unclear what it could mean. And in the Bible, when you have in Genesis the idea that God made the world in 6 days and then rested on the seventh, that is also odd. What does it mean to rest on the seventh? Why the seventh day? Surely if God created the world in the first 6 days and God rests the day thereafter, then God is resting after that as well, on days 8, 9, 10, 11, 12, 13, 14, 15. Thereafter, God is no longer making the world. It has already been made. So the whole idea of Genesis of fitting this into 6 days plus a day, why? Well, the answer is, I think, that God is said to make the world in 6 days for no other reason than that 6 was known to be a perfect number. And why is the week 7 days? Well, for no other reason than that there are 7 planets in the solar system, and the days of the week, there are 7 days in the week because there are 7 planets. Each day is named after a planet. So this correlation between the creation of the world and the number 6 suggests, rather, that knowing that 6 was a perfect number, there was an idea that it should have a significance. It should be given a significance, and that was the significance that it was given. Now, this, by the way, was noted early on by Philo of Alexandria, of the philosopher Origen. Once Christianity and Judaism were developed and were informed by the Pythagorean Platonic view, then these matters were easily explainable, and they were explained, so that there are works by Origen and by Philo of Alexandria which point this out. All right. I said before that the Pythagoreans developed the theory of perfect numbers to a very great degree, and one finds that the report of that in Euclid, who was 300 BC. What Euclid says is truly astonishing. What he says is that there is a connection between prime numbers and perfect numbers. And the connection is this. Suppose you take powers of 2, say you double 2, keep doubling it. 2, 4, 8, 16, 32, 64, etc. Now, consider the cases in these powers of 2 where when you subtract 1 from it, you get a prime number. For example, 4, if you subtract 1 from it, you get 3. 8, you subtract 1 from it, you get 7, prime number. If you take 16 and you subtract 1 from it, you get 15, and that's not a prime number. What about the next one? What about 32? You subtract 1 from that and you get 31. 31 is a prime number. Now here's what the Pythagoreans, reported in Euclid, say. The proof is in Euclid. By the way, we now call these primes that are 1 less than a power of 2, we call them Mersenne primes, after someone who came much later. Mersenne primes. Okay, so that makes it easier to say what I'm going to say. A Mersenne prime is let me say it this way. A Mersenne prime corresponds to that number, that number of triangular numbers. So take 31. The 31st triangular number is the next perfect number after 28. It's 496. 496 is a perfect number. It's the next one after 28. They jump enormously in the sequence. They get larger every time, which is why the Greeks only knew 4 perfect numbers. More were not known until much later. So we have 7 was also, remember, a Mersenne prime. What does it correspond to? Well, it corresponds, the 7th triangular number is 28. Every perfect number corresponds to that nth number of the triangular numbers. If you can work out what the Mersenne primes are, then you can find the perfect numbers by extending the triangular numbers to that amount. And there's a formula for the triangular numbers, so it's not that difficult to do. Now, but at that point it was quite difficult, but that's a phenomenal connection. You wouldn't think that there's any connection between perfect numbers and prime numbers, and yet there is. It's a fantastic connection, astonishing what the Greeks were able to do. And this is in Euclid in 300 BC. Astonishing. What they knew was astonishing. But it has to be said that much of what the Greeks did was, in a sense, a guesswork. They thought that the first 10 numbers were significant, and I think they were right about that. Take 3, for example. 3 is an early number. It's in the Tetractys. 3, and it's also, by the way, a triangular number. 3 is the number of the dimensions of space. 3. That's fantastic. Now, I said that 7 has this sort of accidental connection to the number of planets that they thought that there were. They were wrong about that. We now know that there are more than 7. There are 9. But let's forgive them that. Is 7 an interesting number? Well, yes. 7 is an interesting number. They didn't know why it was an interesting number, but they were right in thinking that it was an interesting number. 3 is an interesting number because it's the number of dimensions of space. The 3 dimensions of space are interesting because on those 3 dimensions you can define what is called a cross product, and that cross product gives you an enormous amount of geometrical information and is immensely useful in the physics in 3-dimensional space. What other dimensions of space could space have which has a cross product? The interesting answer is, not known to the Greeks, but known now, is that the only other dimension other than 3 is 7. 7. So 7 is an interesting number. 6 is an interesting number. 4 is a very interesting number in many ways because 4 gives you the dimensions of space plus time, space-time. That's interesting. 2 is an interesting number. It's the first even, well, the only even prime number. And it's the first proper prime number other than 1, so it's interesting. All of the first 10 numbers are interesting, very interesting. And maths seems to have confirmed that interestingness of the early numbers, just as the Pythagoreans said. But there was a group of Pythagoreans and Platonists who took this in the direction of thinking that there were these special religious significances, just as later authors took there to be 6 days of creation plus a 7th. So the Pythagoreans often attributed spurious or interesting connections to numbers which may seem nothing other than attributions to those things rather than a genuine correspondence. For example, they thought that 2 was the number of femaleness, the female. 3 was the number of male. Why? Why couldn't it be 9 and 8? Why was it significant for 2 and 3? Well, for one reason, it seems. Because 2 times 3 gives 6, and 6 is perfect. And that gives you the union of male and female is the perfect number, the perfect union. That's it, really. So they attributed these things in this way and thought of these things as significant, but what it's really doing is tacking a number onto certain things to make those things numerically significant. It's not finding a numerical significance in things, it's attributing a numerical significance to things. And unfortunately, one part of ancient Greek philosophy was taken up by this attribution of number significance to things. They attributed numerical significances to letters of the alphabet and then multiply them together in a form of code, which is called gematria. This was also something which the Greeks and the ancient world was infatuated with. The number 666 was meant to be a piece of gematria. Then we found out that that was actually the wrong number anyway, and it was actually supposed to be 616. So this 616 was probably some kind of gematria code for someone who was not liked. Probably that's how it went. Who it was, we have no idea. But one interesting thing about perfect numbers you might be interested to know, the Greeks already did know something, that this was probably true. They knew that every perfect number ends in either a 6 or an 8. A 6 or an 8. That's interesting. And with that, I leave you for this week. You can think about these matters and again do your own research and find out your own things about this. It is a fascinating topic, very fascinating. Next week we'll go on to more on the relationship between these religious aspects and the scientific aspects in the ancient Greeks. And I'll go on to one which I think is most significant of all. Okay, thank you.